solution there.
Yeah, that's pretty good.
Pretty spot on.
Don't have to change anything today.
Okay, so polar form, and so what we have here is we have cis theta, and it's short for cos of theta plus I sine of theta. So if you think of what's going on, if we have the imaginary plane and we have some complex number, it has a real component, which is cos of theta, and it has an imaginary component, which is sine of theta. And because we have the imaginary component, we chuck in an I in front of it. And so that's going to give us the resulting complex number. So we're going to start with a series of complex numbers in Cartesian form, and we're going to write them in polar form. So if I have this number 3, all right, if I have the number 3, if I'm to draw that on the complex plane, it's going to be like this, isn't it? It's just a real value of 3. There's no imaginary component to it. It has a modulus of 3. It's 3 units long. So, and the angle is 0. All right, so if I'm going to write it in polar form, I have the modulus cis of the angle. All right, and if you were to type this into your calculator, it'll come out with 3. All right, if I have minus 2i, okay, the modulus can never be negative, all right? So what's going on, minus 2i, that's going to be this number here. It's got a length of 2, the magnitude, the modulus is 2 units, and the angle is pi on 2 units in the negative direction. So this number in polar form is going to be 2 cis minus pi on 2. Very good. Okay, then we have 3 plus 3i. All right, so we need to work out what's the modulus of this complex number, what's the argument of it, and then we can write it in Cartesian form. So this one's going across 3 and up 3. It's going to be up here. So the modulus of this complex number will be the square root of 3 squared plus 3 squared. Okay, the horizontal component plus the vertical component. That's going to give me the square root of 18. And the angle that it makes, because the horizontal component and the vertical component are equal, I know that the angle is pi on 4. All right, we're going across the same amount, up the same amount. That's going to be 45 degrees. Okay, so pi on 4. Otherwise, we can type that into our calculator as we did yesterday, or we can make the manual argument. It's really up to you. But this number in complex form, in polar form, is root 18 cis of pi on 4. All right, so just to explain what's the link between here and here, cis means cos of theta plus I sine theta, right? So one way we could write this complex number is like this: cos of pi on 4 plus I sine of pi on 4. Okay, we could then convert that to Cartesian form using the unit circle, right? Cos of pi on 4, or 1 on root 2. And then if we multiply the root 18 through, we're going to end up exactly with what we had here. Okay? If we distribute the root 18 times cos pi on 4, guess what it equals? 3. Okay? Root 18 times sine of pi on 4, guess what it equals? 3. And there's the I hanging out. All right, let's move on to question 2 then. So we have state the modulus and argument of this complex number. Okay, so the modulus of z is root 2. It's the number in front. It's always, modulus is always positive. And the argument of z is pi on 3. Okay, that's part A. Part B, sketch it on the argand plane. That just means the complex plane. So we'll use both words interchangeably. All right, so the angle of pi on 3 is going in this direction, and it has a modulus of root 2. This is our real axis. This is our imaginary axis. It has been sketched. Okay, part C, find in Cartesian form without technology. So we're going to process this exactly like we did this one over here to demonstrate the link between polar form and Cartesian form. So I've got root 2 cis of pi on 3. I've said that's equal to root 2 times cos of pi on 3 plus pi sine of pi on 3. Okay, we'll look at our unit circle, cos of pi on 3. Now, look, you can bring your own unit circle to the test from now on, but I would expect you to get to a stage where you sort of know it. All right, so I'm looking like here at the unit circle, pi on 3 is up here. Okay, we can see that here. And that means, if I'm looking at that, the x value is shorter than the y value. All right, and so x and y have basically 3 values they take, other than 1 and 0. So it goes from root 3 on 2, root 2 on 2, half. So the x value is half, which means the y value is root 3 on 2. All right, and now we will distribute this root 2, and that will become root 6 on 2. And this is the complex number expressed in Cartesian form. Okay, so I'll get you to just have a wrestle with some of the questions manually, and then I can show you a few tricks to do on your calculator, maybe after recess or something. But today our plan is just C1 and C2. Any questions?
How do you find what theta is for the pole?
Good, yep, so for that one, for like this one, with the minus 2i, so are you happy with it going in that direction?
Yeah.
And are you happy with the size of that angle is pi on 2 units?
Yes.
Yep, and it's in the negative direction.
Yep.
So that's how I've got the negative pi on 2.
Okay.
For the first one, it's just got a real component, so it's going in that direction, which means we have an angle of 0. And for the last one, what I did here, well, I know that it's 45 degrees because the horizontal and vertical component are the same. Otherwise, we can type into our calculator. We have option, complex, and we can type in this complex number and find the argument of it. You remember doing that yesterday? Yeah, cool. So I think maybe Haley will catch up with you, but you fellas will remember that as well. Cool. All right, let's have a crack at C.1.